In this lesson, we are going to combine like terms and provide evidence of equivalence with the expressions with exponents. So these expressions have exponents, and we're just going to show proof because there are some common errors with the exponents when you go to use them as operations, as operators. So let's box our terms first. 3x squared plus x squared plus 5 plus 6. This number seems to not have a coefficient, so let's put 1 there. So 3x squared plus 1x squared is 4x squared. And plus 5 and plus 1 are plus 6. Now remember, what this is really about is taking this first expression and simplifying it to create this second expression. So the expression's 3x squared plus x squared plus 5 plus 1. So this whole thing, remember, is an expression. And 4x squared plus 6, this expression, are equivalent. They just look different. So let's go ahead and show proof. Before we do that, let's decide what x is going to be, or what we want to substitute in. Now remember, x can be any number. But what we want to do is stay away from 0, because sometimes 0 gets finicky because it makes a bunch of things 0. And let's try to stay away from 1. So let's use 4. X equals 4. As long as you're not always using the same one and you're staying away from 0 and 1 for now, we're good. So 3, since it's so long, I'm just going to substitute already. 3 times 4 squared, right here, 4, plus 1 times 4 squared plus 5 plus 1 should be equivalent to 4 times, remember x is 4 squared plus 6. Remember, all I did was put 4, substitute 4 in here, and here, and in here. As always, we do order of operations. We do PEMDAS. Nothing inside of parentheses is left for us to do, but we do have some exponents. So 4 to the second power, 4 squared, is not 4 times 2. Remember, that's 4 times 4 is 16. Now I'm still not done. I still have an exponent here. 4 times 4, positive 4 times positive 4 is 16. Now I'm going to do my multiplication. So we're done with the exponents. Multiplication, division, left to right. So I'm just going to do both of these at the same time in the same line. So 3 times 16 is 48. And a positive times a positive is a positive 16 plus 5 plus 1. 48 plus 16 is 64 plus 5 plus 1. I'm just going to add those together. 64 plus 5 is 69 plus 1 is 70. So all that work, it should be a little quicker over here. So remember, nothing inside parentheses, exponents. 4 times 4 is 16. 4 times 16, well, 4 times 10 is 40. 4 times 6 is 24. So 4 times 16 is 64. And you see how it cut all the way down here instead of doing all that work? And plus 6 is 70. Next example, negative y squared plus 5y plus 4 minus 2y. So my term with the largest exponent on a variable is this first one, but there's no more like it. So let's just bring it down. I'll put it in the corner, that way it doesn't mess it up too much, get in the way. And we have plus 5 minus, well, plus 5y minus 2y. So positive 5 minus 2, or negative 2 plus 5 is positive 3y. And we have this lone constant, plus 4. Remember that this first expression and this second expression are equivalent. They just look different. So the expressions, negative y squared plus 5y plus 4 minus 2y. Remember, this whole thing is the expression. And negative y squared plus 3y plus 4, they are equivalent. They just look different. So we already used 4 in the last one. I guess we can use 3. There's 3 in here already, but it is what it is. I'm gonna prove it using the longer, or this one line with an equal sign. So negative y squared plus 3y plus 4 is equivalent to negative y squared plus 3y plus 4. They just look different. Now I'm going to substitute a number in for y. Before I do that, I'm going to put this 1 so I don't get confused. So negative 1 times 3 squared plus 3 times 3 plus 4 should be equivalent to negative 1 times 3, because remember, substituting y is 3, squared plus 3 times 3 plus 4. Always order of operations. Nothing inside parentheses, but we have some exponents. Positive 3 squared is 3 times 3, which is 9. And that is the only exponent on this side. But we have it again. 3 times 3, 3 squared is 9. And we're done with exponents. So we're going to multiply and divide from left to right. But for our purposes, I'm going to do all the multiplication at one time. So a negative times a positive is a negative 9. Oop, don't want to write that yet. A positive times a positive is a positive. 3 times 3 is 9. And then this one just comes down. Negative times a positive is a negative 9. A positive times a positive is a positive 9 plus 4. Oh, and see, we can already see this. So negative 9 plus 9 will give me 0 plus 4. And the same thing over here. 0 plus 4. I end up with 4 equals 4. Oh, and I forgot again in this one. In this example above, 1770. Yeah, that was good. Just give me some sort of signal. All right, one more to go. So y plus 3y squared minus 4. Let me just start boxing these terms. Y plus 3y squared minus 4y squared plus 5 minus y. I'm going to put that 1 there. I'm going to show that 1 there. So my largest exponent is y to the second. So positive 3 minus 4. 3 minus 4 isn't 1. 3 minus 4 is negative 1y squared. And then my y term is positive 1y minus 1y. 1y minus 1y. 1 minus 1. There's 0 y's. If there's 0 y's, don't write 0 y's. Just don't write it because there's none of them. There's 0 y's, okay? So these kind of just go away. These cancel each other out. And then lastly, we have this constant all alone, plus 5. So the expressions y plus 3y squared minus 4y squared plus 5 minus y, I almost ran out of room there, and negative, I'm just going to write it simpler looking, y squared plus 5 are equivalent. They just look different. So I'm going to go ahead and show the proof the first way, which I just like. It's just a habit I've kind of grown over the years. So I'm going to put them separately. Let's go ahead and figure out what y we want to use. Y equals, we have a 3 here, we have a 4, and I want to use a 3 again. In the practice, no, let's go ahead and use a different number. Let's use 5. So I'm going to write this whole thing out because there's a lot going on there. Y plus 3y squared minus 4y squared plus 5 minus y should be equivalent to negative y squared plus 5. See right here, right here. I'm going to go ahead and write in the ones just so I don't forget about them. So y is 5, so 1 times 5 plus 3 times 5 to the second power minus 4 times 5 to the second power plus 5 minus 1 times 5. Well, that's a long expression. That should be equivalent to negative 1 times 5 squared plus 5. As usual, we will go ahead and use PEMDAS in order to simplify. And there's nothing inside of parentheses, but we do have a lot of exponents as usual. So 5 squared is 5 times 5, which is 25. I just like to write everything beforehand. So, and then right here we have 5 squared. So I'm going to write minus 4 times 25, because 5 squared is 5 times 5, plus 5 minus 1 times 5. All right, so we're done with the exponents on this side. And let's do multiplication and division. So I'm just going to multiply everything that I can, because I'm just going to do this one, and then I would do that one, and then that one, and then that one. But I'm just going to do it all at once. 5, positive times a positive. Well, I should start off with that. Positive times a positive is a positive 5. Positive times a positive is a positive 75. A negative times a positive is a negative. So I'm going to write minus 100. And then plus 5, and then a negative times a positive is a negative 5, so minus 5. Let's go ahead and combine all of these. I'm going to do that a little quicker this time though, or a little differently. This 5 and this 5 cancel each other out. And I'm going to keep this 5 here. And plus 75 minus 100. 75, positive 75 minus 100 is negative, so minus 25. 5 minus 25, there's more negatives there, or you're going all the way past 0. So you end up with negative 20. The negative value here is more than the positive value here. It cancels out and has some remaining. So this whole long thing gave us negative 20. Let's try it over here. Hopefully it's a lot faster. It looks like it's going to be 5. Well, everything in parentheses is done. Exponents. 5 squared is 5 times 5 is 25. We keep that -1 times. And a negative times a positive is a negative 25 plus 5. And there's one, like a larger negative value, so to speak. More negative than positives. So we get -20. And that is it. Thank you.